Today, we're diving into one of the most powerful climatic events on the entire planet, the Indian Monsoon. And let me tell you, this is so much more than just a rainy season. You really have to think of it as this vast, planet-sized engine, a life support system for over 1 billion people.
To really get a sense of how critical this is, let's just start with one number: 55%. That's it. That's the amount of India's farmland that is completely rain-fed, meaning it is utterly 100% dependent on the monsoon showing up and showing up strong year after year. The stakes, they just couldn't be any higher. So what is the monsoon really? Well, at its heart, it's a massive seasonal flip-flop of the winds. And this entire shift, this whole giant system, is driven by a super simple fact of physics. Land heats up way faster than water does. That one little difference kicks off this powerful chain reaction in the atmosphere, flipping the weather from a long, dry season to a really intense, wet one.
So let's start right there. In our first section, we're going to see exactly how this incredible atmospheric event becomes the absolute lifeline for India's economy, its people, and its entire environment.
Just try to wrap your head around this for a second. 75%, 3/4 of the country's entire yearly water supply arrives in this super concentrated 4-month window between June and September. Now, this incredible intensity is what recharges all the groundwater, fills up the rivers, and basically sustains life. But as you can imagine, it also creates these huge challenges of management and, just dealing with that much water at once.
Okay, so now let's pop the hood on this thing. How does this massive monsoon engine actually work? What are the physical forces that get it all started?
It really just boils down to these 3 key steps. First, during the summer, the huge Indian subcontinent just bakes under the sun, right? It acts like a giant hot plate. Second, as this land gets super hot, the air above it heats up, it expands, and it rises. This creates an intense zone of low pressure. It's almost like an atmospheric vacuum. And third, well, nature can't stand a vacuum. All that cooler, heavier, moisture-packed air from over the Indian Ocean comes rushing in to fill that gap. And that rush of moist air, that is the southwest monsoon.
And this slide just lays that core principle out perfectly. You've got this low-pressure zone over the fast-heating land and a high-pressure zone over the slow-heating ocean. Air is always going to flow from high pressure to low pressure, and in this case, it just happens to be carrying a ridiculous amount of moisture with it. That simple temperature difference is the main driver of the whole system.
But it's not quite that simple. There are several other forces that act like massive turbochargers for this engine. You've got the huge Tibetan Plateau to the north, which heats up like crazy and acts like an elevated heat source, making that low-pressure zone even stronger. Then you have these powerful air currents, like the Somali jet stream down low and the tropical easterly jet way up high in the atmosphere. They basically act like channels, steering and accelerating that flow of moisture right towards India.
Now, once this engine is all fired up, the monsoon doesn't just arrive everywhere at once. Oh no, it begins this epic and yet surprisingly predictable journey across the entire subcontinent.
What's so fascinating is the timetable of this journey. You can almost set your calendar by it. It makes its grand entrance right around June 1st on the southwestern coast in Kerala. From there, it just steadily marches north and east, and by the middle of July, it's covered the entire country. Then, starting in September, the whole process just slowly reverses and begins its retreat.
And this advance isn't just one big wall of rain. The monsoon actually splits into 2 arms when it hits the tip of India. The Arabian Sea branch is the stronger of the 2, and it brings all that heavy rain to the western coast. The Bay of Bengal branch, on the other hand, moves up into northeast India, which is home to some of the wettest places on Earth, before it curves northwest and heads into the Great Gangetic Plains.
It's also really important to know that the monsoon is not 4 months of non-stop torrential rain. The system has this natural rhythm to it. It has active periods and then weaker periods, which are known as breaks. And these little dry spells are actually essential. They give the fields a chance to drain and let farmers get out there and manage their crops. But for all its seasonal predictability, the monsoon is also a bit of an unpredictable giant. Its strength and its timing can change dramatically from year to year, and it's often influenced by things happening thousands of miles away.
This chart really puts its importance into perspective, doesn't it? That means southwest monsoon we've been talking about, that's 75% of all the rain. Now, there is a smaller secondary northeast or retreating monsoon later in the year that's really vital for a few southern states, but that big summer event is what really defines India's water security. And this is where it gets really interesting, because the monsoon's performance isn't just a local thing. It is connected to global climate patterns. One of the biggest players is ENSO. That's the El Niño cycle happening thousands of miles away in the Pacific Ocean. Usually, an El Niño event means a weaker, drier monsoon for India, while a La Niña tends to bring a stronger, wetter one.
And it's not just the Pacific. There's a similar pattern happening much closer to home, called the Indian Ocean Dipole, or IOD. It's all about temperature differences between the western and eastern sides of the Indian Ocean. A positive IOD usually boosts the monsoon, while a negative one tends to weaken it. You can think of both of these giant climate patterns as dials that can turn the volume of the monsoon up or down each year.
So this brings us to our final and maybe most critical section. What is the future for this ancient system in a world that is changing so rapidly? What are the challenges the monsoon is facing right now?
And the challenges are really significant. Climate change is making the monsoon way more erratic. We're seeing more extreme rainfall events that cause these devastating floods in big cities, while at the same time, other areas are facing drought. The weird thing is, the overall circulation seems to be getting weaker, but the rain that does fall is coming down in more intense, harder to manage bursts.
Ultimately, this is the big takeaway. The future isn't about trying to control the monsoon. You can't. It's about learning to adapt to its growing mood swings. And that means investing in better forecasting, building agriculture that can withstand the changes, and completely revolutionizing how water is managed so you can capture the rain when it comes and save it for when it doesn't.
And that leaves us with the ultimate question, doesn't it? For more than 1.4 billion people, relying on this atmospheric lifeline is not a choice. So the challenge is, how do you manage a system that is becoming both more powerful and more unpredictable with every single passing year?